Hello everyone, good morning and welcome to the Avi Networks webinar. I'm Praveen Yalagandula. I'm the OpenStack architect at Avi Networks. And today my goal is to convince you that we have a enterprise grade ADC solution, and that is very easy, very simple to deploy, manage, and operate in your OpenStack cloud, and that will reduce your CapEx and OpEx tremendously. So let me start by telling you a little bit about what are the typical OpenStack cloud needs for application administrators. So for application administrators to motivate them to move their applications into their business critical applications into the OpenStack cloud, the cloud needs to provide several types of guarantees. For example, you need to provide tenant and project isolation, SLA guarantees at large scales, and for application, you need to provide high availability and deep visibility and analytics for the application. And for the enterprise grade applications, you need to have enterprise grade application delivery features like encryption and SSL, policy-based load balancing, and so on. And not only this, we need to be able to support for the application delivery, maybe not your non-OpenStack workloads too. You are not going to throw away your legacy servers and move everything. And for some of those applications that are running on your legacy servers, you still need to support them. So given these requirements for your load balancing or ADC needs, what do we have today? You have two implementation options today. One is hypervisor process-based, which is the reference LBAS implementation that ships with OpenStack, HA proxy-based, or you have appliance-based implementation option. That's what you build with traditional ADC solutions with either hardware appliances or virtual appliances. And I will go through these two and talk about why they don't meet the goals that I set out at the start of the talk. So the reference implementation, that's hypervisor process-based load balancer, is very simple to deploy and operate. But when we talk about enterprise-grade quality features that we need, for example, tenant isolation and SLA, the service that you get is best effort only. And there is no guarantees of isolation because all the traffic belonging to all tenants have to go through few network nodes or few places where you run these hypervisor-based processes. And it brings up many operation questions like if you want to scale it or if you want to provide isolation, where do you run it? If you just run it on the network nodes as the reference implementation recommends, then you will have tromboning effect where the traffic has to come all the way to the network nodes and then go back to the compute nodes where your application servers are running. You can run it on all the nodes, but then you may affect your application VM performance as the load balancing, the HA proxy could itself interfere with your application VMs. So this solution is really not so suitable for enterprise-grade clouds. The other implementation is from the traditional ADCs is appliance-based implementation. This is great. Like you have all the enterprise-grade features, but if you talk about certain things like the tenant isolation and SLA, it becomes very expensive to realize it. Like you need to have one or more appliances per tenant, and you need to install one or more per every availability zone. That is, then you are talking about a lot of these appliances. And the operational and management costs are high due to the complexity of the solutions based on appliances today, because these are two device-centric management. Like you are doing individual device management, that is too many touch points. And in many implementations, these appliances are external to OpenStack. You install them in a separate rack along with your OpenStack data center. Or if you're doing virtual appliance based, you set aside several nodes and you install the And this again leads to traffic tromboning, where your traffic has to come all the way to the data center and then go to the rack where your appliances are, and then go back to the compute nodes where your application VMs are. And if you're talking about an increasing east-west traffic in the data center, then that's a lot of back and forth between different points in your data center. And also setting up these solutions is very complex due to dependence on the underlay network. Depending on what plugin you use, what SDN solution you may have in your underlay, you have to tell the appliances and you have to set them up so that they can understand the right encapsulation. And overall, you have limited scalability, especially with virtual appliances, and then you need to do per appliance support agreements, and overall, the operational and management cost becomes very high. So the main point here is you have the traditional appliance-based ADC design that you can do. You get a lot of enterprise-grade features, but it's not very easy to deploy, operate, and manage. You are going to pay a lot more cost. In contrast to either of these implementations, what we have, the AVI network solution, is a cloud application delivery platform. And the principles that we use to build our system is more like a software-defined system, where we separate the control plane from the data plane, and we have a distributed set of data plane service engines that you see at the bottom in this picture. And we have a single logically centralized controller, which is a highly available controller that manages your configuration for all your load balancing. And we have built the system that it is integrated well with the OpenStack components like Nova, Keystone, Neutron, and so on. So the deployment, the management, and operation is pretty streamlined. It's all automated, and it's very streamlined, and it provides a self-service control for the users, for tenants, to go provision the load balancing instances for themselves. And it scales well because of this distributed architecture. And we have built the service engines with enterprise-grade ADC features, and the features that you have available include the SSL termination, policy-based routing, and so on. And per scale, we built these tiny service engines are automatically scaled up or scaled down by the controller automatically, depending on your traffic. Now, this service virtual machine, or this service engine architecture, is very powerful. And note that everything in this picture, like the AVI controller and the AVI service engines, these are all pure virtual machines. So they're all running inside your OpenStack as simple virtual machines. Now, this architecture has tremendous benefits because it makes it very easy to deploy and manage. And it also makes very easy to do isolation and SLA guarantees, because we can spin up the service engines as needed for each tenant separately in their context, and that ensures that you have absolute isolation between the traffic for the tenants. And we do go beyond your typical ADC functionality, and we do provide a lot of application visibility, visibility into the performance of the application. You get Google-like search functionality over the traffic, into the visibility into the application traffic. So let me just briefly summarize the advantages before I jump into the demo and convince you how easy it is to deploy and manage and operate our solution, and also give you a glimpse of the enterprise-grade ADC features that we have. So as I mentioned, AVI Networks solution has all these advantages. It has the enterprise-grade features, plus it's very easy to deploy, manage, and operate. We guarantee tenant isolation by doing per tenant dedicated service engines. We have different deployment options if you have a different model in mind. And we have advanced application delivery features like SSL, policy-based routing, etc. And following the software-defined principles, we have a centralized programmable controller, and it's fully 100% RESTful API, and we run everything as VM. So we are using standard existing x86 machines and no extra SKUs for you to keep around, no additional network configuration, no extra changes needed in your, no extra network steps needed by network admins. So all this means that it gets streamlined. It's very easy to install and deploy. And it's fully integrated in with all OpenStack components, making the auto webinar. Again, as I said, my goal is to show you that it's very easy to deploy, operate, and manage, and then give you a glimpse of enterprise-grade ADC features that we have. But as I mentioned, we go beyond enterprise-grade ADC. It's beyond application delivery features. We provide deep visibility into your application performance. So on the right-hand side, I'm showing you, just giving you a context of what we am going to show you in the demo. So I have two tenants, admin and a tenant one, which we'll call demo in the during the showing the demo. And in the tenant, you have two backend servers connected to one server network. And as I mentioned, everything is VM in our system. So let me go through just with this picture to show you what deployment involves. So the deployment of our system involves just creating a management network that we will use for our controller to service engine communication. And this is just one network that you need to create. And we make it public so we can access it from any tenant. And the second step is just use the image that we provide and install and instantiate a AVI controller VM. Now, that's for the deployment. And once you have the AVI controller up, all you need to do is configure the AVI controller with the credentials for your OpenStack controllers. So you provide the Keystone credentials, and AVI controller basically is initialized. It verifies the credentials with the Keystone, make sure that it can talk to it. It uploads the service engine image, the data plane engine image to the GLAN so it's readily available so that it can spin up instances as needed. And once these two steps are done, that's it. You have an enterprise-grade ADC available in your system, ready to be used. If a tenant wants to use it, let me show you just a couple of steps of what it means to use it, operate and manage it. If a user in tenant one wants to now provide the load balancing for his two backend servers, all he does is create a virtual server with pool with two servers. And then AVI controller goes ahead and talks to the Nova and Neutron to create what the data plane engines and set the right plumbing so that the service engines can provide the load balancing functionality to the backend servers. In this case, I'm showing two service engines because we want to run it in active mode, and they will be, so we have high availability. And now when the regular traffic comes, it just starts to get distributed. And here I'm showing just one service engine being used. In an active mode, both service engines will process the traffic. So at this point, I will switch to our system and walk through the steps that I've shown here, but in a live demo in our system. Okay. So this is your typical OpenStack console. So I'm logging in with the admin. And let me switch the tenant to the admin. And now I'm in the admin mode. So here we have uploaded the AVI controller image already. And all we need to make sure is that we create the AVI management network and instantiate the controller, instantiate a VM using this image. So let me show you the topology. So this is the AVI management network, the red line. And just before starting the webinar, we created an AVI controller instance, as it takes few minutes for it to come up. And so we have the AVI controller instance running on that network. Let me show you that it's been running now. And I have associated a floating IP so that we can access the AVI controller. So that's it. As I said, like the deployment is pretty simple. You create one AVI management network, a public network, and instantiate our controller VM using that image. Now, once the controller is initialized, let me go and walk through the steps of what it is to configure our controller with the OpenStack credentials. So just a couple of steps here. And this is the first screen that you see when you create our controller VM. So it needs few things to make sure that it can connect to your network. Then we'll leave the NTP address there. And I'm going to choose for this is about OpenStack. We'll provide the keystone credentials to our controller. And so at this point, the controller verifies the credentials that we have input with the keystone and make sure that everything is valid. And along with it, it also fetches the talks to the neutron to fetch information about all the networks available, so that we can tell the AVI controller what is the AVI management network that it's going to use to communicate with the service engine instances that it creates. So in this case, we pick up again, the network is going to be in the admin tenant, and if you have multiple regions, they may appear here, and you pick the management network, the AVI management network that we created, and then that's it. So just 4 screens and 20 seconds of configuration, and you have a enterprise-grade ADC up and running in your OpenStack system. Now, so at this point, what's happening is the AVI controller, as I mentioned in the slides, has talked to the keystone and is uploaded a service engine image to the glance. And this is the image that it's going to use to instantiate the service engine instances. Now, let me go and log out from the admin. And as I mentioned, we are all integrated into the keystone. So we don't need to create any more users or accounts on AVI controller. It right away uses the keystone to authenticate any users, give them the right roles, put them into the right tenants, and so on. So now I'm going to log in with demo tenant, a demo user in demo tenant. And once we log in into the demo tenant, it will be placed in the demo tenant context. And now we can create the demo tenant, the demo user can create virtual services, the load balancer instances for their backend servers. So let me just switch to the demo tenant here to show what I have in the network here, what we have in the OpenStack. Okay, so this is the network topology in the demo tenant. As I mentioned before, AVI management is created as a public network, so it will show up in the demo tenancy too. But apart from that, demo has a private network where he has Web 1 and Web 2. These two are 2 backend servers. And we created a couple of clients so that we can drive traffic to these web clients. So let me go back to the AVI Cloud Controller UI, and let's create a virtual service to do load balancing to the backend servers. So I'll go through the basic setup. So we'll do a test virtual service, and I pick some IP address, and we do for backend servers, we can just use the search button available in the UI to get the backend servers, and just pick these 2 for this demo. And then that's it. So this is the very basic virtual service that I created. It's HTTP port 80, and this is the front end IP address. This is the virtual service IP address, WIP address, and then we have two backend servers in this virtual service. And we save, and voila, you have created your first virtual service. Now, as I shown in the slides, at this point, the AVI controller talks to the OpenStack and starts to the OpenStack Nova Neutron components and starts creating these service engines. So here it's created one service engine and started connecting to it. This takes a couple of 1 to 2 minutes. So let me switch to here, and in the meantime show you some of the features that we have available in the in creating like the virtual services and pools and the HA options and so on. So first, let me show you the wide range of high availability options that we have. So each tenant gets to have, they can create multiple service engine groups, and these define what kind of, like what properties of service engines that this tenant wants to create. So in this case, we have the default group, and so we have a variety of settings available, and you can go all the way from shared best effort availability, where multiple virtual services will be created on single service engine, to dedicated resources per application, where each virtual service gets its own service engine. And there are several of other options available in the middle. And as you can see, right now we chose active-active, and so there will be the system will be running with two service engines and will be running with it. Okay, let me show the other features that are available. And for each of these options, you can specify several other options, like how many, you have much more fine-grained control over how many virtual services you want per service engine. So you can, even though it's running, since it's shared active-active, you can have multiple virtual service running on every service engine. And you can specify the scale per virtual service, like you can have more than one service engine serving the virtual service. And finally, you can specify the maximum number of service engines you want for every virtual service. And you can specify like the properties for the service engine. Like if you have an application which requires a lot of CPU and memory for processing, like you have a lot of policies and so on, then you may want to use a bigger SE. Okay, so all those properties are controllable through the service engine group properties. Now let me go to the, so it's still getting the virtual service up. So let me go back there and see what it has done. So the AVI controller, as we were expecting, because it's in active-active mode, has created two service engines and connected them into the network where the backend servers are, and has one leg into the AVI management network. And this is the AVI management network, as I have mentioned before, is used for communication between controller and these service instances. And this front end, the leg into the demo private network, is used for attracting the traffic coming for the WIP address and then forwarding the traffic to the backend servers. And this is a simple example, and you can have a case, you can easily create where your front end is different from your backend network. In that case, the service engines will have two legs, one for the front end network and one for the backend network. So we'll switch to, let me show you the we'll get into the client console. So, and now let's try to access that. I'm trying with the secure. Let's try regularly. So still waiting. Okay, let me go back and show you. Just let's get to this, and we'll go to the real time to see that the virtual service, the back end pool, the controller is determining that it's up, and we'll okay there. So the virtual service has come up, and as I mentioned, we have a lot of visibility into this. I'll come back to that point. But as you can see, the virtual service status says that it's up and running, and the service engines are there. So let me switch to the console, and let's ping this front-end address. And as you can see, we can ping, and let me send some traffic, and there it is. So this is basically showing that we have the basic virtual server running and is available and so on. Now, I'm going to show at this point the steps that I have shown is that it's very easy to deploy, and bringing up operating it, doing the virtual service is creating a virtual service and using it is pretty simple. Now, I'll just quickly go back to the slides and mention a couple of points before I jump again to show a couple of enterprise grade features that the enterprise grade ADC features that we have. So first thing I want to say is that in this case, we did the most common deployment where we install the RV controller in admin, and tenants are using it. This is just one deployment model. But we have our deployment models. You can have a variety of deployment models because this is purely virtual machine-based architecture. So a tenant can simply install both RV controller and have service engines instantiated entirely in the tenant context. So as a tenant, as a user using OpenStack, I don't need to depend on admin to get enterprise ADC features in my tenancy, and I don't need to do a lot of management or develop another orchestration system to create an enterprise ADC in my tenancy. I can just use RV and get everything automated. The other deployment option is, as I show on the left-hand side, the LBAS plugin in the Neutron. You can go through the LBAS API and create your virtual services through there. And in this case, we have an LBAS plugin that talks to the AVI controller, and it's again REST API based because AVI controller is purely REST API. So the Neutron LBAS plugin is simply shipping all the LBAS API calls that we are doing on the OpenStack controller, just ships them to the AVI controller. So we have a lot of flexible options in which you can deploy, either it's a private cloud or you're in a public cloud or you're hosting or you're creating hosted private clouds. This architecture makes perfect sense for you. So let me show you the enterprise ADC features. So the first thing that I'll do is show that we have very good high availability. So I'll let the ping running here, and I'll go. Let's check which one is the primary. So we have two service engines here, as I said. So there's the primary and the secondary, and then I'm going to go just terminate the primary to show that we have a very highly available solution, which should not affect your ping, which should not affect your traffic because it has a failover of like almost a second or even sub-second, much lower than much lower. It just basically takes 1 or less seconds. So let me switch. As you can see, it's basically switched. If you're looking at this, you can see that the traffic switched to secondary, and the controller has created one more instance automatically, uh, and you have again active going on. So let me switch to this and show you that you have just one packet loss that happened, and that's during that one. As I said, it takes sub-second depending on when the ping goes through. You may get one maximum ping that you may lose. Okay, so I have shown that you have a high availability solution. Now let me show you the more juicy parts of enterprise grade applications. So let's go to this and say you want to do SSL. So all you need is just enable SSL, and you can choose whatever profile that you want to. You can create, upload your certificate if you have a SSL certificate, or you can just choose the default certificate that's shipped with the product and save it. So now your front end is also SSL aware, so you can simply use the HTTPS to access your service. Okay, so there it is, and this is your load balancer doing the SSL termination and providing the like SSL termination features with lots of different key support and doing that in the service engines. Now, let me show you one more feature of typical features of enterprise scale ADC, which is policy-based routing. So what we'll do is you may have both 80 and 443, but you may not want your the people to access your service over port 80 at all. So you'd like to do a redirect policy. So as I said, you have a lot of flexibility, a lot of features in this system. So what we are going to do is I'm going to set up a rule, and you can, it's basically a match and action kind of policy that you specify, and we provide a large number of header fields that you can match on. And in this case, I'm going to pick the let's see, the protocol and say anything coming for HTTP redirected to port 443 and with a status code of 302, or we can just say use the protocol HTTPS. And there, I saved it and save. So now you have policy-based routing in effect for this virtual service. So let me switch to here. And now if I try to access it via HTTP, the system should automatically switch to, yeah. So the system will automatically redirect it to HTTPS. And there you have your policy-based, an example of policy-based routing. Okay, so those just give you a glimpse of all the enterprise-grade features that we have. There is a full list of features. You can look at our manual to see the range of features that we have. As I mentioned before, we have features beyond typical application delivery, that we provide a lot of visibility into the application. Now, I'm just briefly talk about it because we are running out of time. As I said, I already mentioned that we do provide a health score, and this is provided based on computing, gathering several hundreds of metrics about your virtual service, about the service engines, about the backend application, and putting together a reasonable number, computing a reasonable health score out of it, and showing how well your application is doing. And we provide deep analytics into several metrics, several dimensions of your traffic, and tell you like how many new connections or how much throughput you're getting in the system and so on. So that's one angle of the analytics. but we also provide very fine-grained information about the traffic. So we collect logs of individual requests, and in this case, I'm just showing the significant ones or the ones where we have seen errors, and this shows a lot of details about the request, about like what operating system or where the client came in, which kind of browser they are using, and which URL that they are trying to access, and so on. That gives you a much deep visibility into your application and allows you to quickly troubleshoot where the issues are. I won't go into too many details of this, and I'll invite you to try our product online. And let me switch and just quickly say that we have our system up and running at several customer sites, and this is one quote from one of our customers where they never had so much visibility and control with so little effort. So that's exactly what I was saying. The 2 points about our solution is that it's an enterprise-grade ADC, and it's so easy, simple to install, deploy, manage, and operate. And we keep hearing back the same 2 things from everyone we work with, all the customers that we have worked with. So to summarize, I've shown you the Avi Networks cloud application delivery platform for OpenStack. As I said, it's enterprise-grade ADC features plus very simple to operate, manage, and that means you have very low OpEx and CapEx. And as I mentioned, we are in production and pilots at about 20 customers, and we are in deep partnerships with OpenStack ecosystem with several OpenStack vendors. And if you want your free trial, please go to avinetworks.com and sign up there, and you can follow us at avinetworks on Twitter. Thank you. And we'll also be at OpenStack Summit with 1 or 2 big customers, and we look forward to seeing there too. Thank you.